Today's lesson is on passing sight distance. This is a continuation from the previous lesson on stopping sight distance delivered by the guest lecturer. Passing sight distance may be limited to 2-lane highways. Hibbard Avenue is a 2-lane roadway. So passing sight distance is limited to 2-lane highways, and on these facilities, vehicles may overtake slower moving vehicles, and the passing maneuver must be made along the lane for the opposing traffic. Notice that when a slow-moving vehicle is moving along the Hibbard Avenue from Computer Center to Portal West direction, vehicles behind are making the passing maneuver from the right lane to the left lane. Let's try to see a sketch showing a slow-moving vehicle and a passing vehicle. The passing vehicle is shown in the sketch making a maneuver from the right lane to the left lane along the Hibbard Avenue. When the road is open in the direction from the Portal West to the Computer Center, there will be an opposing vehicle. So shown in the sketch is an opposing vehicle. The passing vehicle will have to re-enter the right lane. Shown in the sketch below is the indication of the re-entry of the passing vehicle from the left to the right. Shown is the opposing vehicle which had traversed a certain distance from the initial position. And it is shown nearer from the passing vehicle after the re-entry by a certain distance d sub 3. The opposing vehicle traversed a distance d sub 4 during the time when the opposing vehicle was seeing the passing vehicle at the left lane. D sub 2 is the distance traversed by the passing vehicle along the left lane. Shown in the sketch is D sub 1. The passing sight distance is actually the sum of D sub 1, D sub 2, D sub 3, and D sub 4. D sub 3 is usually given. D sub 2 is computed using the formula distance equals time times the speed. The passing vehicle spent time t sub 2 along the left lane. So that time multiplied by the speed of the passing vehicle along the left lane is equal to d sub 2. The d sub 4 is computed using the formula distance equals time times the speed. The time t sub 4 is computed using 66% of t sub 2. So t sub 2 is the time spent by the passing vehicle along the left lane. 66% of that is t sub 4. So t sub 4 is the value that is obtained by determining 66% of T sub 2. D sub 4 is equal to T sub 4 times U sub 4, where U sub 4 is the speed of the opposing vehicle. How about D sub 1? D sub 1 is composed of two distances. One is the so-called perception reaction distance, and the other is the kinematic distance, which is determined by dividing the difference in the squares of the initial and final speed by twice the acceleration. The passing vehicle accelerated, and so there is acceleration. It accelerated because it would like to maneuver from the right lane to the left lane. In the process, the speed is changed from the initial speed to the final speed. So the square of the final speed minus the square of the initial speed of the passing or maneuvering vehicle divided by twice the acceleration is equal to that kinematic distance. That distance plus the so-called perception reaction distance equals D sub 1. The perception reaction distance is computed using the formula distance is equal to time times the speed. The time there is assumed to be 2.5 seconds. And the speed is the initial speed of the passing vehicle. So the minimum passing sight distance will be equal to D sub 1 plus D sub 2 plus D sub 3 plus D sub 4. There is an example problem solving item.